Okay, process for today is not different. I do have on here for the first example, it says sometimes the roots, which again, roots mean the solutions to the equation. So sometimes these solutions are the same number, called a double root. Okay, so we're just going to work through this. Really, the two examples today, it's not a different process from what we've been doing. It's just a different way it could work out. So I have, you have on a different note sheet the steps to take. I have them here for you as a reminder. So we are solving this equation, x squared minus 6x equals -9 by graphing. So first step, set the equation equal to 0. How could I get one side to be 0 for this equation? Casey? Yes, I could add 9 to both sides. So I'd have x squared minus 6x plus 9 equals 0. Okay, so that means that first step, setting one side equal to 0, that step is done. Then it says write the related function or the related equation. So what would my related equation be here, Michael? Well, yes. There was just one thing you were missing, Michael. It does have to do with this, but what would it equal? Not 0, y. Yep, you replace the 0 with y. So you could have the equals y, keep it at the end, or I like to write it in front for the equation. So y is equal to x squared minus 6x plus 9. So you're just replacing the 0 with y. Okay, that's step 2. Step 3 then is now to graph this equation. When we graph, what have we been finding first? The x for what? Or the x of what? What are we finding first when we graph? Okay. And what is this the x value for? The x value of what point specifically? It is on your, it's typed on your sheet what the point is called. The x value of the vertex. Vertex, x value of the vertex. And this is the formula for it, okay? So in our equation, what is our a value? 1, thank you, yes. 1 is in front of the x squared. What is our b value? -6, and c is 9. So if we have x equals opposite of b over 2a, since b is -6, opposite of b is +6, over 2 times our a value is 1. Yep, so this is 6 divided by 2 times 1 is 2. So our x value is 3. And that, again, we're finding the vertex. So our x coordinate is 3. Then we need the y coordinate. How do we find the y coordinate? Casey? Yes, so we put 3 into our related equation for x. So I'd have y is equal to, I do have that 1 in front. You can write that there. But I have 3 squared minus 6 times 3 plus 9. What is 3 squared? 9. And then I'm going to do this multiplication here right away. Then minus 6 times 3 would be minus 18. And I have the plus 9. So if I do 9 minus 18 plus 9, I get 0. Okay, so my vertex, this is my y coordinate then. My vertex is 3, 0. Okay, so I can fill that into my table for my vertex, and then I can also plot that right away. So if I start at the origin, I'm going right over to 3, y is 0, so I'm not going up or down. So it's right on my x-axis. And then I can draw in my axis of symmetry, my line of symmetry, and that just goes that vertical dashed line through my vertex. So through the x value 3. Okay, and then what is the y-intercept? 9. Yes, y-intercept, remember, is your c value, which is 9. So 0, 9. So I can plot that. It's on the y-axis at 9. If I reflect that over my line of symmetry, what other points do I know? All right, x coordinate is 6, y coordinate is 9. So it's a distance from here to the line of symmetry is 3, go 3 to the other side. All right, and then I just have space in the table here to get one other pair of points. So what is another x value I could substitute in, Jennifer? 1? Well, I called on Jennifer, she said 1. You could also plug in -1 if you wanted to. So if we substitute in 1, I'd have y equals 1 squared minus 6 times 1 plus 9. What is 1 squared? Nope. 1. 1 times 1. And then the minus 6 times 1 will be minus 6. And then plus 9. So 1 minus 6 plus 9 is positive 4. So I could plot 1, 4. And then if I reflect that over my line of symmetry, 5, 4. All right, and then we can draw the parabola in. And remember, we're using the graph to solve the equation that we started with. So what are the solutions or solution? Yep, the 3. So the solution is the x-intercept of which there is only 1. Okay, so it's just x equals 3. We had talked about the first day of 9.2, how you can have 2 solutions if you have 2 x-intercepts, or just 1 solution if there's only 1 x-intercept, or maybe you have no solutions. That's also an option. So my solution is x equals 3. And now it says verify your solution by solving the equation by factoring or using factoring. So here's our equation. When we solve by factoring, anyone remember the first step I'd have to do with this equation? When I factor, get it equal to 0, just like when we solve by graphing. So I would add 9. So x squared minus 6x plus 9 equals 0. Then once you have it equal to 0, you look at the other side. What would you check for first when you factor? Casey? GCF? Is there a GCF for this one? No, or they all have 1 in common, but everything has a 1 in common. So there doesn't have to be a GCF. Then I have 3 terms. So if there's no GCF, how do I factor this? Nick? X box method. Okay, so we are multiplying to what? What would go on top of my X here? So the x squared and times the 9 is what we multiply to. The negative 6x is what we add to. So I need 2 numbers that multiply to positive 9, but add to negative 6. Nick? Yep, negative 3x and negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Then in the box, x squared goes in the first box. Then my negative 3x and negative 3x. And then the 9. So what do x squared and negative 3x have in common? X. Negative 3x and 9. Negative 3. And then columns, x squared and negative 3x. X. Negative 3x and 9. Negative 3. So this would be in factored form x minus 3 times x minus 3. I still have the equal 0. And once it's factored, what do I do next to solve for x? What do I do? What are you saying, Michael? Thank you. Your hand was covering your mouth, so I couldn't hear it. So I have x minus 3 equals 0 or x minus 3 equals 0. Now, notice they're both the same. So when I add 3 to solve, I'm doing that for both. So I get x equals 3 or x equals 3. They're the exact same thing. So it's just x equals 3. They're not different. And that is verifying my graph that I only got one solution. Okay, but that is why it's called, so at the very beginning, I said sometimes the roots are the same number, and that's called a double root. This is why it's called a double root, because notice when you solve it by factoring, you're still getting 2 answers, it's just they're the same answer. So that's why it's called a double root. If you want to make that note to yourself, this step right here is why it is a double root or double solution. And then kind of make that connection on the graph. What a double root looks like is when your vertex is actually on your x-axis. Your vertex is your solution. Okay, questions there? Okay, then the second example, I know there's stuff at the top. I want to just look at example 4 first. Okay, let's look at the example and then we'll discuss what's on the top. So we have solve x squared minus 4x plus 5 equals 0 by graphing. Guys, set the equation equal to 0. That's already done for this one. And then it says write the related function or the related equation. So what would the equation be for this one? What did you say, Michael? Yes. Okay, I didn't leave a space for, oh, I did leave a space. It's down here, sorry. I forgot where I even had that. Okay, that's our related equation, replacing the 0 with y. So as we are going ahead to graph then, finding the vertex first, let's look at our equation. What's our a value? 1, B, and C is 5. All right, so 5x equals opposite of B over 2A. B is -4. Opposite of -4 is positive. Over 2 times A is 1. So I have 4 over 2 times 1 is 2. 4 divided by 2 is 2. Why is it a waste of time, Riley? How do you know that? How did you do the problem? Okay, well, you still had to do it to know that it was no real solution. How would you, well, you wouldn't know it's no real solution if you didn't do the problem. Okay, x value of my vertex is 2. Then, if I find my y coordinate, substitute 2 in for x. So I'd have 2 squared minus 4 times 2 plus 5. 2 squared is 4. Minus 4 times 2 would be minus 8 plus 5. Should be positive 1. So my vertex is at 2, 1. So I'll add that into my table. 2, 1 is here. And I can draw in my line of symmetry. Okay, what is my y-intercept? Nadia? 5, yes, so 0, 5. If I reflect this over, what other point would I know? 4, 5, thank you. Now, when looking at this, so which way is this parabola opening? Up. And your vertex is already above your x-axis. So if you were to already think if I drew this in, it's not going to cross. What I would do though, you don't have to fill in the whole table, but I would make sure that I didn't do something wrong here, and I would find at least one other point that verifies it is opening up and I didn't do something wrong. So what's another x value I could plug in? Okay, I heard a lot. I'm going to do 1. Because I think maybe if I did 5, there's a chance it might not fit. Maybe. But 1, 5 fits. Oh, it would just fit, just barely. Okay, so if I plug in 1, I'd have y equals 1 squared minus 4 times 1 plus 5. So 1 squared again is 1, minus 4 times 1 is minus 4, plus 5. So that would give me a y value of -3 plus 5, so 2. So I'd have 1, 2, and that would reflect over to 3, 2. So that helped verify that my other points were correct. It's opening up. It does not cross my x-axis. So as Riley had stated before, it is no real solutions. You're all going to get the homework. Okay, and there's nothing to check. So no x-intercepts, there's no real solution. I'm going to pass this.